The same idea is going to happen anytime we encounter a variable in a problem. Okay? Now variables are just placeholders for other numbers. They're just waiting to have the number put in. We just are not sure what it is yet. It's kind of like those gold bars. We're not sure what it's worth yet. We certainly don't want to give it a dollar figure if we're not sure. Okay? We don't want to take too little. We don't want to take too much. We want to know what it's really worth. Okay? And exchange it for that. So let's take a look at one. If we have 3 apples with 2 cantaloupes, $2, let's say, 4 more apples, and then $5 more sitting on the table. Can we clean this situation up? Can we simplify it and make it a little easier for us to kind of manage? Of course we can, okay? We can put those things that are alike, the like terms, okay, those like items together. Well, the first thing we want to identify is what kind of 3 apples is this? It's clearly a positive. So we're going to look here and we're going to say, are there any other apples to put together? There sure are. Here's 4 apples, here's 3 apples. Well, using our idea from back in combination of integers, are these on the same team? Sure they are. They're both positives. They're going to join up then. They're going to make more of the apples on the table. We know that would be 7 apples. Now, we look at our other numbers. There's really nobody else to put with those cantaloupes, okay? We only had 2. So we're going to just keep them on their own. But when we look at the dollars here, we can go ahead and put them together. Why keep the dollars separate? We know that here's 2 of them, here's 5 more. So altogether we have $7. And what we've done is simplified the situation. We've made it from 5 messier terms into 3 simpler terms. Now I can't put the cantaloupes with the apples. I've never heard of capels or cantaloupes or whatever you want to call them. There's apples, there's cantaloupes, okay? I certainly don't want to just trade an apple for, the dollars. That's not necessarily the value of them. So this is as simple as we can get. There's just stacks of the things that are alike, okay? It's just organizing what we have. Simplifying the expression by combining like terms, okay? There's that word combining again. That's why we got a head start on it, back with integers and fractions even. We're just putting the teams together that go together, the teams that don't, battle it out, using something we know to help us with a more complex idea. Now, sometimes we see our old buddy, the parentheses. Remember, that's like a prison, okay? They're locked in there. So in this case, we have 2 inmates, okay? And again, these are all innocent guys. They've never done anything wrong, so we got to get them out of there, okay? They're falsely accused, just like it's like every movie. It seems like they're always falsely accused, right? They got to get free. Well, here we have a parenthesis situation. They cannot combine, okay? Even though it's a parenthesis, we're trying to put those 2 together. Doesn't happen. So what we want to do is clearly identify each inmate. Positive 2G, positive 3. They can't join together. They're going to go ahead and stay in their separate cells. Well, this 8, he's watching the prison. There's our Maryland policeman again. Okay, it's just a way to understand it. Kind of think about it. Let yourself just have an everyday understanding to something that's a little more difficult. Well, what 8 is he? What's his badge number say? He's really the positive 8. Well, he's not going to be able to go to a single cell to let them out. He's going to have to go to 2 different ones. So he's going to go to each cell, let each guy out. Positive 8 is going to go let out positive 2G first. Positive 8 is going to go let out positive 3 second. Okay, he's got to go to 2 individual cells in the prison. Well, a way to remind ourselves of that is to kind of show us that he's going to travel to each of them. Okay, since they couldn't join together, okay, they couldn't combine, he has to go let them out separately. Okay, so when he lets out this, we know a parenthesis is opened by the multiplication. There's that Maryland police idea again. 8 times 2G. Well, 8 of these 2G, 8 groups of 2G would always be 16 G's. We check to see if it matches. Since it was multiplication, it does. Positive 16 G. Same over here. 8 times 3 never changes. Always 24. Does it match? Fortunately for us, it does. Positive 24. Can we put those together? Probably not. Here's 16 gold bars again. There's $24. You're not going to combine them and say $30 or 30 gold bars, because that's not what you have. That would be a false impression of the situation. So they just have to stay separate. We simplified it down. We got everybody out of the prison. Everybody's happy. Leave it there. Okay? Now, A little more advanced would be this next problem, because we can put all these ideas together and have quite a few operations all in one. So let's look at this next example. 20 with positive 4, guarding the prison with 2x and negative 3, and then another negative 6x over here. Well, let's identify our operation. That's a parenthesis, that's a multiplication, got some combinations over there. You don't even really need the combinations, because you know at the end it's all going to boil down to that, because that's at the end of Pem.C. So especially make sure you identify the multiplication, the division, the parentheses, the exponents. Those are what really matter. So here we are. Who's in prison? Who are the inmates? Well, I see negative 3. That's his little code on his shirt. But which one is this? You know, we want to clearly identify him as positive 2x. Well, can we combine in the parentheses? We know that's first, Pem.C. Doesn't look like it. They're not like terms. This has an X, this doesn't, and we can't put them in the same pile, okay? They can't go in the same cell. So we know that this guy is going to have to let each of them out separately. Now, eventually, what you're going to come to understand this Maryland police idea as is called the distributive property. We're going to distribute this 4 to each of them. He's going to go let each of them out so that they're free. Now, negative 6x will still be there, positive 20 will still be there. Okay? We always want to work down our page so that that positive is not so far away where we miss it. Okay? So what's going to be the first thing we do? Since we couldn't do in the parentheses, we're going to go ahead and multiply them out. Okay? As the result of the distributive property. 4 groups of 2x. Okay? 8x. Positive or negative? Well, they match. It's positive. Positive 4 times negative 3. They don't match. Unfortunately, it's going to be a negative 12, negative 6x. We're looking for like terms. We see a couple sets that match up. This 6x can match up with this positive 8x. This 20 can match up with this negative 12. So I'm going to go ahead and put these x's together. They're on different teams. Okay? They're going to battle out. Which team's going to win? Looks like the positives are ahead. Okay? By how many? Well, they win by 2. But we just have to keep identifying them clearly as, what are they? X's, right? So bring that x along with it. And then positive 20 and negative 12, again, looks like a battle. Who's going to win that battle? Okay, the positives. How many are they going to win by? 13, 14, 15, 16, 17, 18, 19, 20. Looks like 8. Positive 8. Can't put those together. They're not like terms. All right? It's as simple as that. So make sure you think of combining. It's not addition, it's not subtraction. It's a combination of the two. Multiplication and division, we can do at the same time. Multiplication is what lets you out of parentheses. If that's true, division could also let you out of parentheses. That would be like the PD, the police department. They also can do that, okay? So keep that in mind, and good luck with expressions.